Here are the first set of notes for Unit 4. We'll be learning about temperature, thermal energy, and heat. So first up, we need to define these things. Thermal energy is the total amount of energy of all the particles in an object. The units for that, like our other energies, units are joules. Temperature is the average energy of the particles in an object. So just notice the difference there. Temperature is the average. So if you look at one particle, how much energy does it have? Thermal energy is the total. If you add up all of the particles, all of their energies together, then you get thermal energy. So temperature gets measured in degrees Celsius or Kelvin. Heat is the last thing, and this is just the transfer of thermal energy. So kind of like work was the transfer of energy, heat is just the transfer of thermal energy. Units for heat, also joules. The kinetic theory of matter states that matter is made up of tiny particles that we call atoms that are always moving, so they always have kinetic energy. Two objects with different masses will have different energies because one has more particles in it. So the larger object has more particles. So that means it's going to have more total energy. The more energy something has, the faster the particles move. And energy is transferred from particle to particle as heat. So if we take a look at what that looks like, if we look at this animation here, we have the flame on the left side, and notice that as it heats up, you can see each of these just represents like an atom or a molecule that makes up air. So as it heats up, you can see these start to like jiggle a little bit and vibrate back and forth because they are gaining energy from the candle. And then each particle bumps into the one next to it, and it just transfers on down the line, transferring its energy that way. So it's kind of like they just bump into each other, and that's how they get transferred, and that's what heat is. So it's not like an actual substance that's moving, it's just heat is a way to refer to some atoms or molecules bumping into other atoms or molecules next to them and making them start moving. Temperature is the average kinetic energy of the particles in an object. So there are three units that we use. Fahrenheit is what we're familiar with in the United States. We won't use that in physical science. We'll be sticking to the metric system. So the metric system, we have degrees Celsius, and then sometimes it'll be helpful to talk about Kelvin. And Kelvin doesn't have a degrees with it, so you just say like 200 Kelvin is the temperature. You don't say degrees Kelvin. Absolute zero is the temperature where we have no energy whatsoever. So particles aren't moving. So we need to define this lowest point, so we can't possibly go below particles are stopped. We can't have any less energy than that. So that is the lowest point, and that's why that's called absolute zero. In Kelvin, and this is why Kelvin was made, the Kelvin scale, zero is absolute zero. So it starts at the lowest and just goes up. So all of your Kelvin temperatures are positive. But with Celsius, it's negative 273 degrees Celsius is absolute zero. It would be kind of weird to say, like, what's the temperature outside today? Oh, it's 400 degrees. So that's why we come up with the Celsius scale, because then all of the daily temperatures are somewhere around like 20 degrees. Some important temperatures to know in each scale. Absolute zero, so we can look at each of these. Absolute zero, just for a reference point, in Fahrenheit, it's 460 below zero. In Celsius, it's negative 273, and then Kelvin, because it's designed that way, is zero. Water freezes in Fahrenheit at 32. In degrees Celsius, it freezes at zero, and then in Kelvin, that number is 273. Water boils here at 212 degrees Fahrenheit, 100 degrees Celsius. So notice Celsius was designed around water. So freezing point is zero, boiling point is 100. And then Kelvin, that's 373. And then like normal room temperature would be 72 degrees Fahrenheit, 22 degrees Celsius, or 295 Kelvin. When we look at temperature again, the standard unit, that's what are called the SI units for temperature, is Kelvin. So sometimes we'll need to convert Celsius to Kelvin. The way to do that is we just take our conversion factor here, that 273 Kelvin is equal to 0 degrees Celsius. So to get temperature in Kelvin, we just take whatever our temperature in Celsius is and add 273. If we want to go in reverse, so if we're given a temperature in Kelvin and we want to go to Celsius, we just do the opposite of that. So we would go take our Kelvin and subtract 273. So like our example up there, see how our Kelvin, we have a temperature of 373 Kelvin. If we just subtract 273, we find out that's equal to 100 degrees Celsius. When we look at substances, sometimes it will be helpful to draw particle diagrams. So this shows what the particles or the atoms and the molecules that make it up, what they look like. So if we are drawing our particle diagrams, we have a couple rules to follow. So the first up, based on the state of matter, solids should be touching and organized are particles, and we'll see an example of this in a second. Liquids should be touching and not organized, and gases should be not touching and not organized. The kinetic theory of matter, once again, states that matter is constantly in motion, and we want to show that with motion marks. So when we have more marks around an object, that means it's moving more. And we'll see what that looks like in the next example. So take a look at these examples. We are going to draw what each substance looks like, just a simple approximation of what the atoms look like inside of the substance. So a solid, they should be touching and organized. So we just draw it like that. So each particle, we can just make like a circle or a square, whatever shape we want. But notice how they're all touching and organized. Liquids, they're all touching, but it's not organized. So we just kind of randomly draw them around, but they're all touching. And then gases are not touching and not organized. If we split this in half, so we can see what those motion marks look like. If we have a cold gas up top, we just put a little bit of motion on them. If we have a hot gas where they're moving more, we put more motion lines around them just to show they're like vibrating. The last thing we need to talk about is heat flow. So heat always flows from hot to cold. And remember, there's not like an actual substance that's heat. Heat just means particles bumping into one another. So the particles that are moving around a bunch bump into particles that are not moving around a bunch. So we show that, we simplify it with just an arrow, kind of like when we did work in Unit 2. We just show it with an arrow. A larger arrow just means more heat flow. Again, this follows what we did in Unit 2. So if we take a look at an example, let's say we're at a football game on a cold night and we want to drink some hot chocolate. If we take a look, we have the hot chocolate and then the normal temperature hand. Maybe your hand is cold because it's cold outside. So if we want to show heat flow, we know the heat will transfer from the hot object to the cold object. So heat will always go from hot to cold. So we would just show that with an arrow. And that's what we mean by show the heat transfer.